arithmetic progressions. Consider the series, and a series is when you add the terms of a sequence together. A sequence is when you have 2, 5, 8, 11, 14. When you add them together, you get what's known as a series. Now we can very easily see that if we call this the first term, now the term we use here for first term is U1. Okay, you should note that in some textbooks, which are outside the IB, they use the letter A. Okay, so U1 is, and the one's a subscript. Okay, so U1 is the first term. Now you might have noticed this, that if you go from 2 to 5, you have to add 3. And then from 5 to 8, you have to add 3. And then from 8 to 11, you must add 3. Then from 11 to 14, you add 3. This 3 here is what's known as a common difference, because 5 take away 2 is 3, 8 take away 5 is 3, 11 take away 8 is 3, 14 take away 11 is 3. This is known as a common difference, and we use the letter D to stand for that. Right, so from U1 we add D, so the second term becomes U1 plus D, and then we add another D, so the third term becomes U1 plus 2D, and then we add another D, so the fourth term becomes U1 plus 3D, and the fifth term will become U1 plus 4D. Now you might notice there's a pattern here. And you notice this number here, 2, is always one less than the number of terms, because 8 is the third term, this is one less. 11 is the fourth term, and the 3 there is one less than 4. The 14 is the fifth term, and the 4 is one less than the number of the term, which is 5. So if here's n is equal to 1, 2, 3, 4, 5, what we need to do is come up with a formula for finding any term in this sequence. So it's going to be U1 plus one number less than the number of terms. So if it's the nth term, okay, say we call it the nth term, this is going to be n minus 1 times what's known as the common difference D. Alright, and this is the formula for finding any term in this arithmetic progression. An arithmetic progression has the same common difference. Okay, so U1 is called the first term. Note in some textbooks this is written as just A. D is called the common difference, and N is the term number. And so any term can be found by using UN is equal to U1 plus N minus 1 times D. This is a formula which you probably would need to learn. Okay, it's not too difficult. UN is equal to U1 plus N minus 1 D. In some textbooks that will be A plus N minus 1 times D. Right, let's see how we use this with a couple of examples. Find the 50th term of the series 2 plus 5 plus 8 plus 11, which is the series that we had to begin with. So U1 is equal to 2. It's always a good idea to write this sort of information out. D is calculated doing 5 take away 2, which is 3. The second term take away the first term. And N is equal to 50. So you using the formula, and all mathematics, it's always good to write out the formula you're going to use first. So UN is equal to U1 plus N minus 1 times D. So substituting the numbers in, U1 is 2, N is 50 because we want the 50th term. So it's 50 take away 1 times 3, and that becomes 2 plus 49 times 3, which is 149. Find the 20th term of this series. We've got 3 take away 1, 1 take away 5, 5 take away 9, etc. So this series is actually decreasing. The terms are decreasing. So U1 is 3, and if you do the common difference, remember it's the second term take away the first term, you get minus 1 take away 3, which is minus 4. you can also check this. Minus 5 minus minus 1 is also minus 4. And we want the 20th term. Again, you write down the formula. By writing down the formula, also it's a good way of learning it. We put in 3 plus n, which is 20, 20 minus 1 times minus 4. Notice the importance of using brackets here, particularly with negative numbers. Very, very important. So we get 3 plus 19 times minus 4. So we get the 20th term of this series will be minus 73. Okay, so this formula allows me to find any term if I know a few terms of the series or the sequence. Find the sum of the first 100 positive integers. Alright, this is actually an arithmetic progression with the first term being 1 and d being equal to 1. The common difference is going to be 1 each time. So if we write out 1, 2, 3, etc., and then we'll write down the last three terms, which is 98 plus 99 plus 100. And what we want to do is find the sum of adding all these numbers together. Okay, it's actually very easy to do. You can actually do it in your head as well. If you take 3 and 98, you get 101. If you add 99 and 2, you get 101. If you get 101, you get 101. So going back through the sequence, you can do this 50 times. So we call this term here U1, and we call this one UN, the last term. So the sum is 50. Now the 50 comes from the number of terms, which is 100 divided by 2, which gives me 50. So half the number of terms. You take the first term and the last term and add them together. So it's 50 times 101, which is 5050. Now let's just look at this more algebraically. The sum, Sn, will be the number of terms divided by 2. So our number of terms was 100 and we divided by 2 and we got 50 times. Take the first term, and add it to the last term. So we took the first term here and we added it to the last term. Okay, we stand for UN as the last term. In some books they like to use L as for the last term. Okay, so this is one formula for finding the sum of a particular series. Now, this relies as well on knowing actually the first term and the very last term of the series that we're going to add together. What do we do if we just had the first 3 or 4 terms and we're asked to find the sum of the first 100 terms? Well, we know that any term of a sequence is this. So if we take this and place it in here instead of this, which is what I've done here by placing it in red, okay, and then algebraically we have U1 plus U1, that makes 2 lots of U1, we get another formula, which is n over 2, 2 times U1 plus brackets n minus 1 times d. Notice here this would also be like 2a in some books. Alright, so we have 2 formulas for finding the sum of an arithmetic progression. Here they are in red. Okay, again, it's a good idea to try to learn these formulas. I know you get a formula booklet, it's a good idea to try and learn them. Example: find the sum of the first 40 terms of the series 3 plus 8 plus 13. Okay, so we have the first term, but we don't know what the last term is, the 40th term is. We could write them all down, but it'd be a bit tedious. However, we can find the common difference. The common difference is going to be 8 take away 3, which is 5. Just check again, if we do 13 take away 8, that will be 5 as well. So write down a few things. U1 is 3. It's always a good idea to write this down. D is the 8 minus 3, which is 5. And n is going to be 40. Okay, writing down the sum formula, Sn is n over 2, brackets 2 times U1 plus n minus 1 times d. Writing in all the information, we want the 40 terms, it's 40 over 2, 2 times the first term, which is 3, plus 40 take away 1 times 5. So it's going to be 20, brackets 6 plus 39 times 5. So that's going to be You can do this on your calculator, 4020. Alright, so there we have like the introduction to an arithmetic progression. So 3 formulas, one for finding a particular term, and 2 for finding the sum of a series.